Hello, welcome again. In the previous lesson, we learned how to expand some few binomials and we understood what the meaning of a binomial. We said that a binomial is an expansion where we are having more than one term. A binomial is an expansion that includes two terms in one bracket and then they are raised to a given power. Those kind of expansions are what we call binomial expansion. Now, I want us to try the following, and then we're going to come up with what we're calling a Pascal's triangle after the following expansion. Example 1, a plus b raised to power 1. We all know if you take a number and then raise to power 1, it becomes the number itself. So this one should give us a plus b. Now, what about a plus b raised to power 2? This one we had already worked out earlier, and it was a squared plus 2ab plus b squared. Then the next one, a plus b cubed. This one we worked out and we found that this one gives us a cubed plus 3a squared b plus 3ab squared plus b cubed. Now my question is, what is the coefficient of a and b in each of the following expansions? In the first expansion, this is 1 and here is also 1. Then in the next expansion, we have this is 1, 2, and then 1. The next we have 1, 3, 3, 1. Now the question is, where are these coefficients coming from? Where do they come from? That if you arrange these coefficients for the first expansion, we are getting that the coefficient is 1 and 1. Then, what about this? It is going to be 1, 2, 1. Then the next one, it is 1, 3, 3, 1. Where are these coefficients coming from? 1, 3, 3, 1. Where do they come from? If we had started with a plus b raised to power 0, we know that a number raised to power 0 gives you 1. So meaning, if we started from power 0, power 1, power 2, as we move forward, we end up with the first one is 1, the next is 1, and then 1. Then the next, we are having, this is for a plus b raised to power 2, it is 1, 2, 1. Then the next, a plus b raised to power 3, it is 1, 3, 3, 1. You can see that this one is forming something that looks like a triangle. What we come up with is something that looks like a triangle. So now, that kind of arrangement is what we are calling Pascal's triangle. So this one is normally available at the back of your mathematical table. There is a table there that shows, it is called the Pascal's triangle, that shows the coefficients of x when you expand a given function to a given power. So now I want us to come up with those particular coefficients. Assume up to power 10. So these are the coefficients from power 0 up to power 10, which we are going to use as we do the expansion. But don't struggle to come up with this table because in your mathematical table, there is a table that analyzes the coefficients from power 0 up to, I think, power 10. Check at the back of your mathematical table. You'll be able to see those particular coefficients given, that it forms a triangular shape like this. This is triangular in shape. So this is now what we are calling the Pascal's triangle. So it helps us to get the coefficients when we raise a given binomial to a given power n. N can be any number. Example 1. Use the Pascal's triangle to expand the following expressions. Number 1, x plus 2 raised to power 4. Now this is very simple. From the table that we had just drawn, the following are the coefficients. When we talk about power 4, these are the coefficients. The coefficients of power 4 is 1, 4, 6, 4, 1. So we are going to draw a table like this, and then we have 1, 4, 6, 4, 1. The power 4 is here, and these are the coefficients starting from 1, 4, 6, 4, 1. I hope you have understood how we are getting them from the table. We draw a table like this for coefficients. So we're told to expand x plus 2. So we're having two terms. The first term is x. So for x, we're going to start by having x raised to power, the highest power, which is power 4. And then we're going to decrease the powers going towards the end of this table. So we shall start with x raised to power 4. The next will be x raised to power 3. We are now decreasing the powers. X raised to power 2, x raised to power 1, and then finally x raised to power 0. Then the other one, we are now moving to the second term. We have done expansion of the first term, which is x. The next term is 2, positive 2. So we shall now have, for the second term, if we started with the descending powers of 4, the second term we are going to be expanding in ascending powers of 4. So we shall start with 2 raised to power 0, 2 raised to power 1, 2 raised to power 3, power 2, and then 2 raised to power 3, and then 2 raised to power 4. And then from there, we are going to multiply 1 times x raised to power 4 times 2 raised to power 0. And then we give the value. 1 times x raised to power 4 is x raised to power 4. 2 raised to power 0 is 1. So it's like saying 1 times x to power 4 times 1. What you end up with is x raised to power 4. That is the value of the first. So you start from 1 going down, you multiply going down, and then you find the result. So this should give you x raised to power 4. The next is 4. So it is 4 times x cubed. 2 raised to power 1 is 2. So 4 times x cubed is 4x cubed. 4 times x cubed is 4x cubed. And then multiply this by 2. It gives you what? 8x cubed. The next is 6. 6 times x squared is 6x squared. What is 2 raised to power 2? This one should give you 4. And 4 times 6x squared should give you what? 24x squared. I hope you are able to see how you are getting those values. The next is when the coefficient is 4. When the coefficient is 4, this one, 4 times x raised to power 1 is x, and then times 2 raised to power 3. And 2 raised to power 3 is 8. So it's like saying 4x by 8. 4 by 8 is 32x. Then finally, when we're talking about coefficient of 1, the last one is 1 times x raised to power 0. A number raised to power 0 is 1. So therefore, this x raised to power 0, it becomes 1. Because any number raised to power 0 is 1. Then 2 raised to power 4 is 16. So it is going to be 1 times 1 times 16. And this one gives us what? 16. The final answer therefore will be x raised to power 4 plus 8x cubed plus 24x squared plus 32x plus 16. This becomes the correct expansion of that binomial. I hope you are able to understand that. If not, then pay attention for this second example to understand more. Second example, 2x plus y raised to power 6. So the first thing is to come up with the coefficients. Starting with the coefficient, let us write them down. Coefficient when power is 6, we have 1, 6, 15, 20, 15, 6, 1. So it is 1, 1, 6, 15, 20, 15, 6, 1. Those are the coefficients. Then we're now going to start with the multiplication of 2x raised to power 6, the highest one, then 2x raised to power 5. Remember to put this 2x in bracket, then raise it to power 5, then 2x raised to power 4, 2x raised to power 3, 2x raised to power 2, 2x raised to power 1, 2x raised to power 0. Then we are done expanding the first one. The second term is y, so we shall now have y raised to power, because y is just y, so we can just no need of writing it in brackets, so we shall have y raised to power 0, y raised to power 1, y raised to power 2, y raised to power 3, y raised to power 4, y raised to power 5, y raised to power 6. Then now let us multiply these going down. What do we get when we start multiplying them going down? Then we get the result. So now let's start with the first one. 1 times 2x raised to power 6. So in this case, be very careful. If you're having 2x raised to power 6, that one means it is 2 raised to power 6 by x raised to power 6, because the entire 2x is raised to power 6. So you need to find the value of 2 raised to power 6, and 2 raised to power 6 is 64. And then x raised to power 6 is x power 6. So therefore, already here we are going to have 1 times 64 x power 6, and then y raised to power 0 is 1. So we end up with 64 x raised to power 6 as the answer. 64 x raised to power 6 for the first one. Then the next one, as we said earlier, it is 2x raised to power 5. That is where you may make a mistake. And if you raise 2x to power 5, this should give you 32x power 5. And then now this is what you multiply by 6, and then finally multiply by y raised to power 1. So you're supposed to get 32 times 6, and 32 times 6 gives you 192. So this should give you 192 x raised to power 5 y. The next, 15 times 2x raised to power 4 times y squared. So you need to find the value of 2x raised to power 4. 2x raised to power 4 should give you 16x power 4. And then you now work out 16 by 15. What do we get when you take 15 times 16? That one gives you 240. So the answer here should be 240 x squared. Sorry, x power 4 y squared. X power 4 y squared. Then we move to 20 times 2x cubed times y cubed. 2x cubed should give you 8x cubed. Then 8 times 20 is 160. 8 times 20 should give you 160. So this one should be 160. X power 3, y power 3. Then we move to the next one. The next one is 15 x squared. 15 times 2x raised power 2 times y power 4. 2x raised power 2 should give you 4x squared, and then 4 times 15 is 60. So this should give you 60 x squared y power 4. Then 2x raised power 1 is just 2x. 2x by 6 should give you 12x y power 5. Then finally 2x raised power 0 is 1 times 1 to give you y raised power 6. So therefore the final answer here should be 64x power 6 plus 192 x power 5 y plus 240 x power 4 y squared plus 160 x cubed y cubed plus 60 x squared y power 4 plus 12 xy power 5 then plus y power 6 as the final answer. I want to believe that you have understood how that expansion works. Let's see example 3. X minus y raised to power 4. So when power is 5, these are the coefficients. It is 1, 5, 10, 10, 5, 1. So the coefficients will be 1, 5, 10, 10, 5, 1. Those are the coefficients. So we start with x to power 5. We move to x power 4. The next is x power 3, x power 2, x power 1, then finally x power 0. Then we move to this one, put in bracket because we're having negative y raised to power 0, negative y raised to power 1, negative y raised to power 2, negative y raised to power 3, negative y raised to power 4, negative y raised to power 5. Then now multiply this going down. What will you get? 1 times x raised to power 5. Negative y raised to power 0 is 1 times x power 5 times 1, which gives you x raised to power 5. Then we move to the next one. 5 times x power 4, that is 5x power 4. Then remember, you are having negative y raised to power 1. That one gives you negative y. So if you have 5x power 4 times negative y, you end up with negative 5x power 4y. So this should be negative 5x power 4y. So the negative is coming from the fact that negative y is raised to power 1, and that one gives you negative y, and if you multiply the two, you end up with negative 5x power 4y. The next, 10 times x cubed, that gives you 10x cubed. And then negative y squared simply means negative y times negative y, and negative by negative is positive, so you end up with y squared, positive. So therefore, when the power of y is of a negative number is even, the result is positive. But if it is odd, the result is still negative. So we shall have 10x cubed times y squared, and this one should give us 10x cubed y squared. The next is 10 times x squared times negative y cubed. We shall have now, this is negative 10 x squared y cubed. The next is 5 times x times y power 4. So this one should be positive because the power is even. So positive 5x y power 4. Then the last one is 1 times x raised to power 0 is 1. And then negative y raised to power 5 should give you negative y raised to power 5. So the final answer therefore is x power 5 minus 5x power 4y plus 10x cubed y squared minus 10x squared y cubed plus 5x y power 4 minus y power 5. This is the correct expansion. Let's do the last one, and then you will pick the other three to practice. We're having a half x minus y raised to power 6. So the coefficient is 1, 6, 15, 20, 15, 6, 1. These are the coefficients. And then we now write, starting with a half x raised to power 6, a half x raised to power 5, a half x raised to power 4, a half x raised to power 3, a half x raised to power 2, a half x raised to power 1, and then a half x raised to power 0. Then we move to negative y raised to power 0, negative y raised to power 1, negative y raised to power 2, negative y raised to power 3, negative y raised to power 4, negative y raised to power 5, negative y now raised to power 6. And then we multiply going down, and we find the value. Then we add or subtract depending on what the powers were. 1 times a half x raised power 6. A half x raised power 6 should give us 1 over 64 x power 6, and then negative y raised power 0 is 1. So therefore this one gives us 1 over 64 x raised power 6. The next, a half x power 5 is 1 over 32 x power 5. Then that is what you now multiply by 6. What do you get if you take 1 over 32? So that is same as saying 32 6 over 32, and that is same as 3 over 16. If we simplify by 2, so this one gives you 3 over 16 x power 5 y power 1, or just y, but now it's supposed to be negative, should be negative 3 over 16 x power 5 y. Then the next, 15 times 1 over 2x raised power 4 is same as 1 over 16, so times y raised negative y raised power 2, that is going to be y squared. So we shall now end up with 15 over 16, 15 over 16, 15 over 16 x power 4 y squared. The next is 1 over 2x cubed times 20. 1 over 2x cubed is 1 over 8x cubed. So a half cubed is 1 over 8. That is same as saying 20 over 8. And 20 over 8 is 2.5. So we get 2.5 negative y, because y negative y is raised power odd, negative power 3. So we shall have negative 2.5 x power 3 y cubed. Then the next is a quarter x squared times 15. So that is same as 15 over 4. And then times y power 4. So we shall have this is positive 3.75, positive 3.75 x squared y power 4. The next is a half times 6 is 3, so we get negative 3 x y power 5. It is negative because negative y is raised power odd, power 5 is an odd. Then finally minus plus, sorry, because this is negative y raised power 6, so it becomes plus y raised power 6. So the final answer is going to be 1 over 64 x power 6 minus 3 over 16 x power 5y plus 15 over 16 x power 4 y squared minus 2.5 x cubed y cubed plus 3.75 x squared y power 4 minus 3x y power 5, then plus y power 6. That is what you end up with in terms of expansion. So try the following. Try these 3 arena for your practice. Goodbye.